so that by the time you're done with organic chemistry, you will take a look at any question whatsoever. So I want us to look at different questions and their structure. So let us take a look at question 8. And looking at this structure, this is CH3. I want to see, by the time we've done series of examples, you will be able to know how to name any hydrocarbon whatsoever. Any hydrocarbon given to you, you will be able to name any compound. So we have CH2 and CH3. So let's make this clear. CH2, CH3. So what will be the name of the compound above? Looking at what we have, it is clear that the straight chain is our parent chain. The straight chain can be our parent chain. So just to make it more simple, for simplicity, the straight chain can be our parent chain. And now, where do we take our numbering scheme from? If we are to go from the left hand side, this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. But if we choose to number our parent chain from the right hand side, this will be carbon 1, carbon 2, carbon 3, carbon 4, 5, and 6. So it means that this is side chain and this is another side chain. This side chain is methyl. This is methyl side chain, and this is ethyl side chain. So if we are to number from the right hand side, our ethyl side chain falls under carbon 3, while the methyl falls under carbon 5. If we are to take our numbering from the left hand side, our methyl will fall under carbon 2, while the ethyl falls under carbon 4. So which numbering scheme should we follow? Is it the right hand side or the left hand side? We ought to consider the side chains now. Methyl and ethyl, who is larger? We've seen this rule. There is a rule that says when we have this type of numbering scheme, we have to give preference to the side chain that is larger. The largest side chain takes the lowest number. So since ethyl is larger than methyl, we ought to follow the side that will give ethyl the lowest possible number. So this is a question to remind us of the rules we have been saying before. So automatically we follow from the right hand side, and that will be 3 ethyl. That will be 3 ethyl, since ethyl is at position 3, coming from the right hand side. So this will be 3 ethyl, and methyl is at position 5. 5 methyl, and the parent chain is 6 carbon atoms. So that will be hexane. 3 ethyl, 5 methyl, hexane. And it's as simple as ABC. That is it. So can we take a look at another example? Let us take a look at that again. So we have another like this. So this is the 9th one. We have compound CH3, CH2, CH, CH3, CH, CH2, CH2, CH3, CH, CH3, CH, CH3, and CH3. So this is what we have. Now, looking at what we have there, the next thing that comes to mind is what will be our parent chain. Now, a student may choose to go this way, straight. You may choose to go straight, and then every other thing outside that parent chain becomes your side chain. That is, we have 3 methyls, and this drop down, this is C3H7. That is propyl. This is propyl. We've been seeing ethyl. Ethyl is C2H5. Ethyl. Now we are seeing C3H7. This ought to be C3H8. But because there is the loss of one hydrogen atom, is going to be propyl, not propane. So this is propyl. So you see, so this is just to make us understand that that is propyl. In case this is the right one to use, this is C3H7. That's propyl. Just to make us understand it. But I think this is the first time we are meeting something like this. So if the stretch chain is our parent chain, then it means we have 3 methyls and 1 propyl. But another student may choose to go this way. Some other person may choose to go this way, taking your count. Some other person may choose to take his count this way. Some other person may choose to take his count this way. 1, 2, 3, 4, and then 5, 6, 7. You see? Some other person may choose this counting. 1, 2, 3, 4, 5, 6, 7. And another student may choose the straight one. So whether you're taking the straight chain or you're taking the L-shaped chain, all the same, we'll still be having something. So it's still 7. There are still 7 chains. 1, 2, 3, 4, 5, 6, 7. So, or 1, 2, 3, 4, 5, 6, 7. Some other person may choose to go right hand side. Some other may choose to go the left even. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So whichever way, whichever path you choose to follow, it is still going to be 7 chains. So a rule says when we have different numbering schemes like that, we should better take the straight chain for simplicity. So let us go with the straight chain. If we choose to go with the straight chain, then it means let's just carefully erase what we have here so that it's going to be clear. So let's carefully erase this. For students who choose to go this way, always remember that if you count straight and you count any other way, if it gives you the same thing, please always settle with the straight chain. Always settle with the straight chain. So let's just leave it at that. Let's just leave it at that so that we can proceed. Let's just leave it at that. Okay, so we have this. We have this. Now, it implies therefore that if we choose to settle with the straight chain, it means this is going to be our side chain. This is also going to be side chain. This is going to be side, and this will be side chain also. So it means we have three methyl, and we have, this is propyl. It's going to be propyl. 3 methyls and 1 propyl. So where do we take our numbering scheme from? From the left or from the right? If we choose to go from the left, if we choose to take our numbering scheme from the left, this will be carbon 1, 2, 3, 4, 5, 6, and 7. But if we choose to come from the right hand side, what will be our numbering scheme? This will be carbon 1. This will be carbon 2. This will be carbon 3. This is still carbon 4. This will be 5. This will be 6. And this will be 7. So if we choose to number from the right hand side, that is to say we are numbering from the right with blue ink. If we choose to number from the right, we are going to have 2 methyl. The first methyl will be at carbon 2, the second methyl will be at carbon 3, and the third methyl will be at carbon 5. Our propyl still remains at the same position, whether from the right or from the left. Now, if we choose to number from the left-hand side, the first methyl is at carbon 3, the second methyl will be at carbon 5 with red ink. The left-hand side is the numbering on with red. The numbering scheme on red is from the left-hand side. So if we are numbering from the left-hand side, our first methyl side chain is at carbon 3, the second is at carbon 5, and the third is at carbon 6. Our propyl remains the same at carbon 4, whether left or right. Now, if we choose to number from the right-hand side, which is on blue ink, our first methyl will be at carbon 2, which is on blue ink. Our second methyl will be at carbon 3, and the third methyl will be at carbon 5. So, which numbering scheme is the best? Since the propyl remains the same, at the same position, whether left or right, propyl remains at carbon 4. So that implies that numbering from the right-hand side is ideal, because there are 2 methyls found closer to the right-hand side, and that will give them 2 and 3. But if we are to number from the left-hand side, it will give them 5 and 6. So it means numbering from the right-hand side is ideal, since propyl, which is the largest side chain, remains the same. Whether left or right, it still remains at the center, it's centralized. So that will make us to come from the right-hand side. So numbering from the right-hand side is ideal in this case. So that means the name of this compound will be 2. Don't forget, M comes before P, propyl. So it means our methyl comes first. So this automatically will be 2, 3, 5, 2, 3, 5, trimethyl. Methyl comes first. Forget about the tri, because the tri only tells us that there are 3 of them. 2, 3, 5 trimethyl, 4 propyl, heptane. So that will be the name. 2, 3, 5 trimethyl, 4 propyl heptane. That is the name of our structure. 2, 3, 5 trimethyl, 4 propyl heptane. That is the name of our structure. So it's as simple as that. So take note of it. So we have to come from the right-hand side, because the 2 methyls that are there are at position 2 and position 3. And the third methyl is at position 5. But if we are to number from the left-hand side, we are going to be having 3, 5, 6. That will give them higher number. So it gives those 2 methyls higher number compared to, since our propyl is centralized. Coming from the right or coming from the left gives us the same number, which is 4. So we ought to follow the side that will give these methyls lower number as possible. So that is actually what we have. So having seen that, let us proceed. So we are looking at next. Let's look at another question.